Hello friends, welcome back to my another video, and in today's video we are going to cover light chapter. Okay, light. So in my previous video I have told you about that what is light. It is an electromagnetic radiation, and what are the two form of light: particulated, wave, and how we can see any object, right? So now this is my second video on light. Okay, so now let's start our video with spectrum. What is a spectrum? Now, if you have seen a prism, it is like mm, pyramid shape. Okay, it's like something like this. So when the white light enter the prism, and when it exit the prism, it's split into 7 colors. Okay, we all know rainbow is consist of 7 colors. The same 7 colors are present here. Okay, so when they split, the white light split into the 7 colors, that 7 colors are known as spectrum. Okay, so white light splits into the spectrum, and if again we when the seven light again get into some inside some prism, okay, then it again converts into the white light. Okay, so white light is converted to the spectrum is converted to again the white light, and this happened due to the prism. Okay, so now what basically happened that as you all know, my favorite topic is space. So in my last video also I've used example from space, and in this video also I will use some example of space as it's my favorite topic, and obviously I can't left it over. So now think this is our sun. Okay, this is our sun, this is our earth. Okay, this is our earth. Now what happened that the sun's photon particles that travel through the vacuum of the space. I've covered what is photon particle in the last video, and I will send the link in this video. Okay, and yeah, in my last video I made two video. They are of same topic. You can say they are same video, but I have just changed the language. My first video was for English, second video was for Hindi, and same I will do with this. I'm making the English video right now, and afterward I will make Hindi video. Okay, so now let's continue to our topic. So our light photon particle are coming towards the earth. Now what is happening that this light color is white. Okay, this light color is this photon particle, which color it is carrying is white. Okay, now what happened that sun has the atmosphere. Okay, sun has atmosphere, and we also have atmosphere. So while the photon particle are getting from the space, and when it enter into our atmosphere, so what happened that water droplets also work like same as the prism works. Okay, so in our atmosphere there is water droplets, right? Now what happened that this light interact with water droplets, and it made the spectrum. Okay, now when it make the spectrum, what basically happened that after that we can see the blue color. Okay, we can see the blue color, the sky. But as I said, it consists of many others color also. They have 7 color, then why we only see blue color? Like red, it contains yellow, it contain, and even green it contain, but why only we see blue? It's because the wavelength of the blue is very small. Now if we all know about frequency. Okay, if not, I will tell it in another video when I will make for the sound. Okay, we will get to know what is frequency. While just understand like this, we all know frequency, and the waves that are made. Okay, think this is my frequency graph. So what happened that between the distance between two crust, okay, the upcoming part are known as crust, and the downgoing part, okay, the part that has gone deeper than the line are known as drought. Okay, so the distance between two crust or two drought is known the wavelength. Okay, so now when the wavelength is very small, very less, at that time the color of that wavelength will be blue. Okay, so if you have ever noticed, when the sun is above the horizon and means it is afternoon, the sky will be full of blue. But when it's evening, at that time you will notice that the sky will be orangish. Okay, now why it happened, as I said earlier, the wavelength, when the wavelength is less, then the color will be blue. Okay, okay, so now if the wavelength is more, okay, now wavelength is more, it is more than the first one. Okay, let's take it first case, and this is my second case. The wavelength means, let calculate it from the crust. Okay, see, they are far, the two crust are far from each other as compared to the first case, right? So means that the wavelength of the second case and first case are different, and the more the wavelength will be, the reddish the sky will be, means the reddish the color will be. Okay, let's take one more example from the space only. Now let me clear this first. Now you have listened that, like, here is our earth. Okay, this is our earth, and from here we are using a telescope, a very powerful telescope. Just say for example, space webb telescope. Okay, James Webb's telescope. Yes. Now let's take an example that this is our earth. Okay, this is our earth and we are living on it, and we are using very powerful telescope. Okay, let's suppose James Webb's telescope. Okay, so we are using that telescope to see the farthest galaxy, to see the farthest galaxy. And let's suppose that galaxy is present somewhere here. Okay, now that galaxy is present somewhere here, and we are seeing it from here. Okay, from our that telescope. So now what we will see, that that galaxy, I hope so you are seeing it clearly. Okay, just a minute. Yes, still okay. Now you can see it properly, that galaxy, you will see that galaxy somehow reddish in color. Now why reddish in color? As I said earlier, okay, as I said earlier, the more the wavelength will be, the more the wavelength will be, the reddish the color will be, because the red color has more wavelength, has, okay. But the blue color, when anything like let's suppose moon, if we will use that telescope to see the own moon, first of all we will not able to see, because it will give us that much magnification that we will not able to understand, right? If you ever used your mobile and you have just zoom it to the 20x, and now I will put that mobile and seeing my board, will I be able to see anything? No, I will not, because it has zoomed a lot. If I have to see that board, I have to go further and further. Okay, let's take an example for this. Okay, so right now I'm on 10x, and let's go near. Think that this camera is James Webb telescope, and the board here, let me zoom out. Here as you can see it is written light. Okay, it is written light. Now this word light is my moon. Okay, and I am this much close to it. Okay, I'm this much close to it, and my magnification power is this much. Are you able to see that H properly? No, because the camera is little bit unsteady, right? First of all, it is little bit unsteady as it is moving. Okay, in the space, the telescope is moving, and second thing, that is too near that the pixel form we can see. Okay, so that means, but if I go a little bit further from it at a perfect point, now can you see that H properly? Right. So what I want to mean that as the James Webb telescope is very close to that and it has very high magnification power, that's why we are not able to see moon properly. But just suppose if we see the moon, then the color you can see right now, we will see the same color. Okay, we will see the blue moon actually when we take a picture from James Webb telescope, but we are not able to take, as I have given the reason. Now let's take an example that this is our earth. Okay, this is our earth and we are living on it, and we are using very powerful telescope. Okay, let's suppose James Webb's telescope. Okay, so we are using that telescope to see the farthest galaxy, and let's suppose that galaxy is present somewhere here. Okay, now that galaxy is present somewhere here and we are seeing it from here. Okay, from our that telescope. So now what we will see that that galaxy, I hope so you are seeing it clearly. Okay, just a minute. Yes, still okay. Now you can see it properly. That galaxy, you will see that galaxy somehow reddish in color. Now why reddish in color? As I said earlier, okay, as I said earlier, the more the wavelength will be, the reddish the color will be, because the red color has more wavelength, has, okay. But the blue color, when anything like let's suppose moon, if we will use that telescope to see the own moon, first of all we will not able to see because it will give us that much magnification that we will not able to understand, right? If you ever used your mobile and you have just zoom it to the 20x, and now I will put that mobile and seeing my board, will I be able to see anything? No, I will not, because it has zoomed a lot. If I have to see that board, I have to go further and further. Okay, let's take an example for this. Okay, so now, so the wavelength is more, that's why we will see it reddish, that galaxy reddish in color. So now did you understand what is spectrum and how we why we see the galaxies that are far away from us reddish? Now there's a, and one more thing I want to tell you, that do you know there is a galaxy that is older than our universe? Right, you heard that right. That is older than our universe. Now this is a suspense for you. If you want to know which galaxy is it, you can scroll my YouTube channel video, or you can search "This Galaxy Supports My Theory" by ASR Aditya Singh Rana, or else I will give the link in description, you can go through it. So this is for today. Meet you in another video. Jai Hind. Take care. Bye bye.